relying upon previous stuff. So I had to scour the questions in here
You missed
to
a
figure out
little
which
bit.
ones were just this material versus also
Yeah, not my
usable
problem.
material. So I had to filter through it, so we'll kind of see how far we get to. Here we go.
This is 10, right?
Sorry.
This is chapter 10.
This is 10. Okay. You're 10. 11 is reactions of alcohols. 12, I think I saw some stuff on spectroscopy there, which is a newer
It's
thing.
gonna listen to that. We Arab said, Mr. Prashant forgot to record. He said, you missed a little bit.
Which part did you miss?
He did it.
The whole thing.
Okay. So,
Oh, you weren't recording. You were
No, I forgot to click record.
You
it's,
forgot
what
to-
is this?
I-
Well, let's hear
I,
it.
I mean, it's just, you know,
can
he
pause.
got the notes.
He has the ability to pause, right? Now, so just a Grignard reagent is another way to make an alcohol, right? So, in this, you have to go ahead and take some kind of alkyl halide, which you've seen tons of, and you throw in magnesium with it. It's going to replace and switch this R, technically a carbanion, really. Okay, so to be honest, it's not a covalent bond. It's not a true covalent bond. It's really an anion and a cation together. It actually flips places. Okay, organic lithium can be used, but it's going to be the carbanion, the R group is going to be your main focus. Just like when you're making acetylide ions, the R group of adding it to it would be the same idea. Okay, so in this, you have to have two pieces of it. One, you do want to have the R group that you're going to add on to it here, and then also you need to have the carbonyl turns into an alcohol. Okay, so you have an alcohol with an R group being added together. Okay.
Is there any reason why you use this method over any of the others?
This is actually more carefully controlled.
Oh my god, yeah.
Because before, and the other stuff you did before is like, if they had too many equivalents, you might, like alkynes, you might tetradiol, or tetra, whatever, OH it.
Yeah.
Right? If you did diol, for example, like ozonol, it's so, okay, to synthesize them. Okay, to synthesize the Grignards. Okay, first off, Rx plus two equivalents, one equivalent of Mg in ether. That will form your actual Grignard. Okay? For this one, you must use ether. The reason why, if you have anything in there that is any kind of a protic solvent, it's going to react to that preferentially. So water, alcohol, anything like that whatsoever, it's going to react with it. In our grad school laboratory, in our research lab, we had an ether still. Usually you distill alcohols, typically, right? Just alcohols, distill hexanes, stuff like that. Ether's explosive. So you couldn't use like a regular like metal type of container to go ahead and distill it. You had to use ground glass, only glass. So that stuff, you literally had it heating up with this desiccant. Do you guys know what a desiccant is?
A drying agent.
Yeah, so if you remember like way back when and Bennett, you guys probably had like a jar that had like these little
White
like purple pellets in the
Yeah.
bottom, right? That was a desiccant to keep things dry. You would put that in there with the ether and also distill it on top of that. It was scary as all hell. Okay? If you use lithium instead, with hexanes, you'll get out the lithium version.
And this is called organolithium.
Difference is you have got to use ether for the Grignard at the top of magnesium. For this one, you can use other alkyl solvents. So if hexane's not available, you have octane. You can use octane instead, for example. Okay. So if you have to make it first, you take the alkyl halide, work with magnesium in the process of ether, create that. Now, once you've made that, if you need to,
Does it say hexanol?
hexane. And no alcohols with this, nothing that is like O group with it. Ether can do it, but OH is ROH is no way. Okay? So this is going to be Grignard reaction now. So not synthesis of it, but Grignard reaction.
We can use other, what was it, alkyl?
Alkyl solvents. So hexane, octane, nonane. Can't use methane, it's a gas, right? It's gotta be a liquid version. So butane, pentane, hexane, etc. Hexane is the most common.
So
of
any
them,
ane, pretty much.
as long as it's a liquid.
Has to be liquid ane.
Okay. So once you've made these Grignard reagents, there's the RMGX or RLIX. Once you've made them, now you can use them. And the reactions they can undergo are with aldehydes and ketones. Okay, in general, the aldehyde or ketone, putting it in there. So first step is to add the R group to it. Okay, then the carbonyl part's going to go and swing upward, make the oxide, and then you protonate it to make the alcohol. Okay, the easiest way to do it is show the map for you here.
So that would be the Grignard
That's the
reaction.
so this is the Grignard reagent reacting with an aldehyde or ketone.
What's to the right of magnesium?
Br.
Oh, okay.
So does it basically take that extra oxygen off the carbon? Because the
No, because it's using
wait,
it.
no,
It's
that's right.
using it to make
So
OH.
it adds the
Yeah.
H.
Kind of remember how before the carbonyl of the other ones swung upward, right?
Yeah.
But like you added the acetylide ion, it would grab on. It's a similar idea.
Okay.
Really similar idea to the acetylide groups.
Wait, what does double prime mean again? Or
That means there's going to be so R means one kind of alkyl group. R prime means another kind of alkyl group. R double prime means a different kind.
Oh, okay.
So I'm going to show the mech with respect to that.
Bro, you did not know
I
that, bro.
knew that.
No,
That
you-
was an old.
No, you didn't, bro.
Stop being in
You did not know
denial.
that, bro.
Stop being in denial.
Alright. So first step, this thing's going to nucleophilically attack. Remember, it's technically a carbon anion, really. Okay, so our carbon anion's going to go in there. Hop. Okay, first step, okay. So R. There's O. Oxidon. R prime. There's the R double prime then. This guy added. It's a pretty easy Mac if you think about it. It's like the acetylide one for the most part. So just think like this. Right? It's like an R group, right? Similar idea. This is a carbon anion, just like the acetylide was, right? Same exact idea. It just doesn't have to have the alkyne group in it, that's all. So do you remember how we just showed that one to make more carbons in a chain? In the beginning of the question, remember the question you guys had 32, right, for chapter 9?
Oh,
Was it how to make
NaOH.
more, how to make R groups, right? Make them larger.
Oh, okay.
This is another way to do that,
Oh.
okay? And that R group, and it does it really quickly, and it does an OH on top of it at the location.
So is
if
this
you need
better
to.
then?
Depends if you need an OH or not. If you need to make an alcohol at that position, then absolutely is the way to go. If you don't, you can add it later. That's kind of your decision. Okay, are we good so far? So then your protonation comes in. Right, protonation up. Okay. So if I used a ketone, what did I just create?
If you you made a ketone with
I
it?
used a ketone here where these are both carbon-carbon groups. What did I just make here? What kind of alcohol?
Tertiary.
Tertiary. If I used an aldehyde, what would I really create?
Secondary.
There you go. So there's the difference between the two. As far as aldehydes can create secondaries, ketones will create the tertiaries.
So ketones tertiary. and
Because you have two carbon groups, right, to the left and right, respectively the carbonyl. But if you have only one, then you can't make three. You gotta make two at the most.
aldehydes are
Aldehydes work, yep,
secondary.
yep, except for one kind of formaldehyde, right, which can only make.
One primary.
Okay. Do you mean to show you that, or do you think you got that? Okay. Just a reminder. Formaldehyde with the Grignard.
So tired.
Right, that's going to create the primary alcohol.
Bro, let's drink this.
Regular aldehyde. That's going to make the secondary. And then your ketone will make your tertiary.
Or should I get over schools online?
So it's just a synopsis of what would happen. You guys explained it back to me just fine, but that's a quick synopsis of it. Okay, do you see how like the MGBR thing, I'm really not even using it whatsoever?
And they
Mac.
only use one prime, not two prime.
I could use whatever, it doesn't matter. I just chose some kind of alkyl group that's different than the others, whatever it is. Or it could be the same, doesn't matter. Okay, is everyone okay? Everyone's got the Mac written down first? Yep. Okay. Alright, practice time. Okay. Put this with
Practice time.
Alright. See what you guys create.
That's a ketone.
Okay. Now pH, you guys know what that stands for?
You know,
Phenyl, okay? So benzene ring.
so do you add that?
You're adding a whole benzene ring to this thing. So you're gonna make a tertiary, right?
Yeah.
So it's gonna go here, 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 here. This O was the carbonyl, now it's the alcohol. And this
Yes,
R
phenyl.
group got added on, that's the phenyl. If I were to draw the whole thing out, it looks like that.
Oh, so you have to make it. Okay. I
Yeah.
see.
So again, this is an easy way to add R groups to something else.
Is it
So,
attached to the same carbon as
Same
the
carbon,
other?
same carbon, so it's gotta be the alpha carbon where the nucleophilic attack occurs.
Get bit by a mosquito.
If I was talking like this to my advanced chem kids, they're like, "What are you speaking?" Because they barely understand nucleus. You know, so. Well, think back when, like when you guys did chemistry, like, you probably lost most of it after your first year. Then you came back and did AP if you did.
Yeah.
And it kind of regurgitated a lot of it again, right? And it recycled, but it was a deeper level. And remember your first time you guys made Lewis structure, like H2O can't be bent. What do you mean symmetrical? Mm-hmm. Yeah, right? The old stuff, right? All right, let's go.
No touching.
All right, let's go here.
Nobody's touching.
There you go. Good shot.
That's an aldehyde.
It is.
So secondary.
Okay.
So then
Just
just one thing attached below.
1, 2, 3, 4. Right. That's gonna stay the same. This becomes the alcohol. Something down below. It's 1, 2 carbons. 1, 2 carbons.
And what happens to the MGBR?
It's still floating around in there.
Oh, so you just get rid of anything attached to that?
Yeah. The focus with the focus of the mechanism is always on the carbanion, which is the R group with the negative charge.
So you just leave the R group on there.
How did we gain a carbon?
So remember, this is only 2 carbons. 1, 2 carbons.
No, from the original structure.
From here. 1, 2, 3, 4. 1, 2, 3, 4. Oh, 8.
Oh, okay.
Yeah, so now Okay. And then let's try this guy then.
I think he's actually gonna watch
Okay, he did come. Okay, if he's watching, one of the say Scooby-Doo is next minute.
Alright,
Yeah,
this was a little
right.
tricky.
Scooby-Doo.
Okay, so what's gonna happen here?
That looks like a ketone as well.
Well, we're not gonna open up the ring then, right? Because that means the
Yeah.
carbonyl becomes just the
So you just
OH.
have two attachments.
It stays there.
Is
And
there
you
two
just
OHs? Or
That
no?
was it
It's
isopropyl.
isopropyl.
Is it Markovnikov?
There's no Markovnikov to do it here. That's across the double bond, which is CC. This is just adding to a C carbonyl to make the OH.
Oh.
Okay? The nice way of showing you guys this would be I'm giving you the Grignard reagent. That's the nice way. Okay? But I showed you earlier how you could make one. You could take something like a bromine group and add what to it to make it a Grignard.
Yeah, MG.
Mg. So I added Mg in the presence of ether, right? Can't use a regular alkane solvent.
Yeah.
So Mg with ether. Then you would add in this component. So the actual substrate itself would be added second. So if I added this in,
Wait, how do you know if it's Mg versus 2Li and hexane?
so usually it'll be the magnesium. Like the lithium's a very rare one.
Okay.
Rare.
Oh, so you're saying this is a two-step reaction? So first
So
you make
the-
the Grignard.
Yeah, so first step you're doing is you're making the Grignard from this,
Yeah.
which would be technically like this thing. And you're gonna add it with this thing, which is
Which
now
is
shown here, right?
Oh, okay.
So it's another way to show it, just be aware.
Okay.
And then of course the last step is you have to protonate it
Because
again,
the
right?
watermelon
Deprotonate, sorry.
is
So
stronger.
it's be, oh, protonate, H+, sorry.
Why does there have to be a phenol ring?
No, it could be anything.
Okay.
Anything that's juice phenol in this case.
So that's more like how a problem would look.
It's hard to tell. It's hard to tell exactly what it might look like. Either way, if you see Mg involved in any shape or form, it's somehow you're either creating the Grignard or it's already made in it.
Okay.
So here it was already pre-made,
Brand.
right? Here it's not pre-made.
We haven't used the Mg for anything else.
We never have. Okay? Alright, so if you make that, this is your Grignard done, right? We're okay with that? That's the Grignard. So it's after step one, which really means you really have this thing. Right? Technically. Then you're gonna add that where on this funnel?
The bottom one right next to. Oh no! Why at the end?
It's gonna go right there, right? Because this O becomes OH, and this part adds here. So it's 1, 2, 3. 1, 2, 3.
So much Scooby-Doo.
2, 3. 1, 2, 3. Can't add it. Okay, how we doing? Yeah, it's just another way to look at it. I'm putting two things together, right? Irregardless. Question is whether I use one as a reagent or one as a reactant. Doesn't matter.
So you can use 3?
You're gonna use one thing, one combo.
I see.
You could put 3 in there, and I guess you could compete. I don't know what would be the answer then, but you could make a mixture, I guess.
Scooby-Doo.
Mg. Okay. How about this guy? First step. Take that guy. That guy's going to be the Grignard. It's really technically a negative charge right here, right in the carbon. Not really happy about having it, but it has it. Okay, so really you technically have this. right, for the Grignard. So then if you put that with the carbonyl here, what kind of carbonyl is that? Aldehyde, ketone, formaldehyde, what?
It's a formaldehyde.
Yeah, so what kind of alcohol forms?
Prime.
What kind of alcohol forms? What number?
One.
Primary, there you go. So if that's the case then, right, he's there, right? So then the CH2O adds, right? So this is adding on to a carbon, double bond, O, H like that normally, right? But then this becomes the OH.
Yes. Green.
Okay, cool.
Can you just go over the thing with the H2C double bond? though?
Yeah, so it's kind of like if this is the H, like this is the guy that's being added here.
Okay.
So then this becomes a word like it's what for. So that's the OH there. This is the aldehyde original there too. There's the other H, aldehyde.
How does it just kick the MGBR out?
It's just out. It's positive charge.
What if she just rose up?
It's ionic. It's charge based. I'm not breaking out a covenant monitoring thing.
The sound, you know.
Okay, doable, not doable. Doable? Okay. So what are the other kind of carbonyl compound things we've seen before? It's not an aldehyde, it's not a ketone, it could be a what?
Ester.
Or,
Carboxylic.
oh, look at that.
Very nice.
Okay. And you guys saw last time that if you oxidized further an aldehyde, it made a carboxylic acid, right?
Yes.
Okay, so you know there's kind of like, you can kind of start thinking about it as like I can start grouping things together, like these can do the following. This marker's sticking like crazy here. Alright, so now it's a reaction between Grignards again. With esters and acid chlorides. Acid chloride is like that. So it's a derivative of a carboxylic acid. Okay, so for esters, we take an ester, and if we use excess, so we use a lot of Grignard. And then of course propane at the end, we actually get out two separate alcohols. Use an acid chloride. If you use excess again. With H3O plus, we get out a tertiary alcohol, just like you do with the ketone.
Ooh, this is excess what?
Of the reagent, that's the Grignard. So add more Grignard than you had to. Okay. All right, so here's the mech.
Oh, that's the one. Two separate alcohol.
Are you okay if I use ME as an abbreviation for CH3?
CH3, sure.
Okay, the reason why I'm saying is because it gets confusing of which carbon's which then, okay?
Wait, what does that say over there?
Two separate alcohols.
No, to the left of it.
Excess MGVR, or RMGVR,
No, the
acid chloride,
oh, FCD.
not acetic, over there. So acid chloride is just basically a chloride instead of an OH on a carboxylic acid. Okay,
That told me
so
it
with this one,
It doesn't, bro.
does.
No, it doesn't, bro.
Yes, it does.
okay, we use R prime as our
You're
grouping.
like horny schizophrenic.
R prime comes in,
No, or what to say?
leave of attack.
No.
I see that. It's AC4.
Okay, so that right there's your first step.
I just see stuff like
That's the first step. Second step then would be
Wait, what's the bond in between the R and the O?
where at?
On the left one.
Here? It's a
No.
single bond.
No, far. Right underneath mech.
Over here?
Yeah.
Cardinal,
Is that line a bond, or is that just showing where the arrow is?
where the arrow's going. This one, you read that?
Yeah.
Have they ever asked you to prove a mech in like something?
Mine, yeah.
Oh my god.
And I go say like, here's your starting, here's your ending. Show me mechanism how to get there. It might be 3 steps, and you gotta show all 3 mechs.
Wow.
That's an intense kind of question, right?
They don't ask
And
that.
I don't know whether or not your exams are different or not. Sometimes your exams are during the regular class period, like a 50-minute period, right? Usually an
Yeah.
hour.
Those are like 2 hours.
Sometimes they get 2 or 3 hours.
Extra?
Like 2 or 3 hours, like tests, like exams. Like you have 3 hours to complete this 15-page exam. Go.
Oh my god.
Kind of thing.
Wait, 15 page.
Usually,
Oh my god.
grad schools works just 5 hours.
That is
Final
a-
or tests?
Dude, if I have a test after that, I'm cooked.
I've already looked at some of
My
your
master's
like,
defense was 8
college
hours.
exams. They're so much longer than like.
No, we take exams.
All right. So here's the thing with this guy. This is not very stable as is, right?
No.
But we learned earlier that you can have alkoxides that are somewhat stable. That will form an alkoxide if we take a lone pair, make that carbonyl
Double
again,
bond.
and pop that guy off. So that will form our carbonyl R prime. You see that R prime moved up?
Yes.
So this is the original Grignard that now makes the ketone. But what else formed?
OME.
Mm-hmm. Remember that, okay? It's still in there. So then what's gonna happen? Well, if I actually have this structure here, and I add it, remember it's an excess. Excess means more equivalence. Right, that guy in there still, what does that mean it's gonna do? It's gonna attack the ketone, which we just saw would happen, right? So
So
then
we
R,
should attack it.
C, O, minus R prime, and another R prime. And then what's gonna happen? Well, now you wanna actually go ahead and protonate it, right? Because you can't have a leaving group with just R, it has to be an OR to make that work. So we'll use H3O plus, that's fine. If we want, we can show it like a little more officially there, like that. Option comes
Wait,
in.
how can you have 2 R prime groups, can't you?
Because the first R prime group added when I took the ester and made the ketone. Now the
But
ketone.
wouldn't it become R double prime then?
Nope, they're the same
Oh,
one.
because they're the same
It's
group. I see.
excesses, it gotta be the same one.
Is that H3O plus or H2O2?
That's H3O plus, I'm showing the H off of the O to show the H3O plus, that's all. You can show however you want. I'll draw the whole thing out for you.
So H2O makes deprotonates it?
So it's protonating it.
Protonating it? I mean.
Yep. So it's gonna protonate it. Boom. So this makes your tertiary alcohol. Right? But over there it says we have an ester that makes how many alcohols?
2.
I wonder if there's another group in there still that could still be protonated.
Another group?
There he is. Okay, so we also have the O and E in there as well, right? So that happens, and you make homie, right? Or home, where you want it. Okay. Okay, get the idea? So basically, the way to look at it is your esters, you have 2 kind of components. You have
What's
your
up with this?
O part and this part, right? 2 halves.
Wait,
The
how,
fingers so much.
But,
wait, so, okay, that grabs an H.
so the first step
Right.
is this guy attacks.
I mean, like at the bottom, like the last 2 steps. So this,
Let me make that just real clear.
well, it was the last 2 steps. So
Right here.
basically,
So you have this alkoxide's in there, right? You just formed that with the addition of that second equivalent of the green reagent. You okay with that?
Yeah.
So then I can protonate that guy.
Right.
I can't redo the carbonyl here because I don't have an OR group to leave. I did originally. And that OR group is still hanging out there.
How is it become
That's the one that gets
HOME?
So that's what's happening. In that first step, right? You have this guy atom form. This is the leaving group in
Yeah,
that second
that I
step.
get.
That's him.
But why? How can they attack the same hydrogen?
It can be either one, and two equivalents of it doesn't matter.
Yeah, wait, how can it
Wait,
attack the same hydrogen if it's, you know, you
Oh, it'd
already
be like a
been
different
pronated
one?
with the.
Oh,
Oh, they
Or you
use
need to
two of
see-
them?
Yeah, well, it's H2O3 plus, a ton of it in there.
just in there.
Yeah,
Bert.
grab it. Yeah, it's not gonna grab two of them in hydroxide, it's not gonna do that.
Right.
but-
I thought, that's why I was
No, 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 no. Okay, so does that kinda make sense?
Yeah.
Alright, so.
How do people survive?
How do people take this class, right? Like,
They don't.
and think about it too, you guys have had how many hours of actual time?
Oh my god.
Like, think about, well, your class, I'm guessing they're like 3 hours per week, is that about right?
Yeah.
Yeah, so 3 hours per week,
Mine's 4.
or 4. Well, is it organic lab too, or no?
Lab is in.
Is lab included in that 4 hours? or
I
no?
don't think so.
Okay,
I'm
so
taking,
it's-
like,
if it is, then it's
separate
like another.
semesters.
Our organic was like 5 credit hours, so you got 3 for lecture and 2 for lab.
That's
It was-
what mine
it was
is.
One
two
for
separate.
lab.
We had 2 separate like 3-hour labs though, so it counts as only 2 credits still.
Oh,
That's
so you
hellish.
get one.
Are
credit
you doing
for 3 hours.
Orgo lab in the
That's
same
yeah, so I do
semester?
too. I
Yeah.
had 2 labs.
Do you have another lab too?
And for Orgo 2?
No, like
Yeah.
you have Orgo lab. Do you have like a biology lab?
Yes. I might drop that.
It's not uncommon to have like 18 hours like lab time during that.
Wait, why don't you take it like the next semester?
That's what I'm thinking.
That's what I'm doing.
Because I have MCB, but there's no lab for that.
Yeah.
I might
I
do
took
that because that might be smart. Because if I drop the Orgo lab, I mean the bio lab, then it might make it easier.
Wait, what's hard about MCB? Those
It's
What's MCB?
molecular cell bio.
Oh,
Yeah.
that's horrible.
Oh,
Really?
Yeah.
no, dude.
I heard it's easy.
People say it's like, oh, it's super hard, but
No, because it's so much memorization.
if you just do all the homework, like every assignment, then well, because ours was curved. Because for us, it was like 88 was an A. Because normally a 93 would be an
Yeah.
A, but he curved
For
it.
us, it's like 93 is an A, but if you go to recitation, you get, and like full participation is like an extra 10% to your grade. So it's basically like an 83 kind of. So,
So you do it.
Oh, that's easy.
So then
then.
I heard it's not bad to get A.
You have to take IB too, integrative biology.
All right, you guys ready? Okay, so this is gonna be ester. It's gonna undergo Grignard.
Bullshit
So
class.
what does one product have to be?
So fucking
First one you can see right away.
Ketone.
I'd see the isopropyl alcohol on the right hand side. I know eventually this is going to be a leaving group, for sure,
How do
right?
you know that?
Because over here it was in that second
Oh,
step,
right.
right? So I'm just seeing that right. That's my
So
first.
wait, I
spot.
don't understand. With that, why couldn't you go straight to the ketone and then just
You can, yeah, you can. Whatever
and
you
just
want to
add the MG? I mean the.
do. You can. So I'm not going to show the mech, right? I'm just going to show the final product. So if I know this is going to happen, I know this oxygen has to be the alcohol of it. So let's make that guy. I know that I'm going to have to add 2 equivalents of this. So I've got a 1, 2, 3 carbon structure. So that's a 1, 2, 1, 2, 3 carbon structure. I'm doing it not once, but twice.
Wait, why is it twice?
Because I had to do it here and here. First one here, the ester became a ketone, and then the ketone got hit again,
Oh, I see.
second time. So that's one product, and the other one would have to be the second
Huh?
part of the ester, which is not a homie, right? It's a, what the heck that thing is?
I'll do it at that.
Wait, so that's the mechanism with ester, acid chloride.
Ester, just ester. Acid chloride, we're not showing that. It's the same idea though. Because you won't have the.
So wait,
ester
how,
part.
I don't understand. How did you know that the 2 R groups are going to be on there again?
Because I
Like
had
based
these-
off this structure.
So I had 2 equivalents, right? It's an ester. This is an ester by definition, right? The O is in the middle there.
Oh, that's an ester.
Yeah.
That's why.
Wait, so why did we do? Oh, it's just R single prime, 'cause it's
Yeah.
the same one.
So you're adding 2 equivalents of the Grignard because you need to make the first one has to go on there to make the ketone part.
And then you have
Then the
homie.
second part comes in to go ahead and make the alcohol part. And then because you don't have a good leaving group here anymore, you can't go any Grignard anymore. It's done. So then you have to protonate to make the alcohol at the end.
So you have isopropyl.
Okay. So this kind of reaction, same thing, works the same way. Let's
I
just
see.
say-
So only when you have an ester. What about lithium?
Lithium's the same thing.
Same
with
thing.
that.
So
Yeah,
if
the
you see
same thing
lithium
there.
in there, then
Yep. That was an acid chloride like this. Okay. With acid chloride, I put that with, let's just make it ethyl. MgBr, H2 plus. Okay. This is what's going to happen now. First step is going to be the attack, right? So you guys come here, pop, CH3CO, right? Cl. There's my R group being added. 1, 2, 3.
Wait, where'd you add the H?
1, 2, 3. Where?
To the O. To the second.
Not yet. Not to the end.
Oh, so this is the mech.
Not to the end, yeah. So this is the O. I'm only showing you the mech for this one to show the difference. So the reason why this, guys, ready? Ready? The reason why this can also work with the chlorides is because chloride's a good leaving group. So this thing can go back down and pop off the chlorine, right? So when it does that, there's 1, 2, 3. 1, 2, 3. So that's really what happened in that first step. Can that thing be attacked again by a Grignard?
No.
Yeah, it can.
I thought we said just a tertiary alcohol.
But it doesn't have to be.
Wait, what?
This first, well, you
so
remember
wait, the
though.
Cl acts as a leaving group.
Yes.
Is there any reason why we redraw the, 3 carbon
You
to the
can do
right?
it however you want, doesn't matter.
Oh, so
So-
you get rid of the double bond off the O, and then you can
Right,
make
so
an
same thing here, right?
H3O.
So here you have the nucleophilic attack, right? Where the single bond O alkoxide forms. Same thing happened here. Then the carbonyl forms and the chloride came off. Here it was the OMe came off. Same idea. Leaving group has to be there. Then that allows for a second nucleophilic attack by another Grignard, the same Grignard if you choose. Hey, guess what? Could you possibly use a different Grignard, guys? Maybe you could. Look at that. You get different R groups now, right? You could definitely do that for synthesis
So
questions.
the chlorine leave.
Yeah.
Wait, why is the chlorine leave?
Cl minus is a good
Oh,
leaving
so
group.
just go- okay.
So then I have another one of these R, well now I have choice in it, but.
Wait, is it the same one?
Mhm.
Okay.
So then that's gonna also pop. And then 1, 2, 3, 1, 2, 3, like that. That has no leaving group left, so what am I forced to do? I can only propionate now. H plus comes in, pop.
So wait, how did you get 2 of the same groups?
These I used the Grignard twice.
Yeah, but what in the reaction led you, tells you that you can use it twice.
Yeah, it's excess, right?
Where does it say that?
That was the part we said
Like
earlier.
I get up until the last step where you get rid of the Cl.
Alright,
and-
so you're good here.
Yes.
Go to the leaving group. Go to ketone formation.
Yes.
You're okay with the ketone. Earlier we just saw the ketones can also undergo this to form secondary alcohols, right?
Yeah.
So then this forms, right? R comes in, R prime. What happens now?
So then
I don't have another leaving group like I did up here.
Oh, so but then
So I'm stuck.
how did you know that your MG isn't your MGBR used already once you're making?
If it says excess, you can keep going. So
Oh,
that's the
does
reason
it
why.
say excess?
So that's the thing with ketones and aldehydes, you don't have access. You have one shot and that's it.
Isn't
With
that a
esters and
ketone?
acid that's an ester.
Oh, ester.
Ester up there, right? Esters and acid chlorides, you get 2 shots. The reason why is the first is to go to create the ketone, and the second one is to nucleophilic attack that ketone again.
I
So it's
see.
2. That's why you'll always have 2 groups of the same kind. That's another like telltale sign. If you have like dimethyl on the same carbon, diethyl, whatever that is, that's a really good sign that you have something going on here with a Grignard.
Yeah.
As long as there's an OH on it too.
Yeah.
Okay? You okay with that?
Yeah.
Yeah. Okay, make sure. Okay. Because the whole idea is that you have to make, esters make 2 alcohols, right? And the one alcohol is the one that pops off first, and then the other one's going through the whole process. With the acid chlorides, you don't have a second alcohol, you have just the one tertiary that you created, that's it. There are no other ones in there. Okay, you're sure you're okay on this, Matt?
Yeah.
absolutely you're going to see this sometime in your organic class. And then most likely it'll probably be draw the mechanism.
Will be a what mechanism?
Oh, they're going to say draw the mechanism for this.
Oh, draw. Oh, okay.
Almost guarantee it. Guaranteed the ones you're going to see. SN1, SN2, E1, E2. Right, for sure. Hydration, acid catalyzed across
Like,
the
how
middle
would the
strand.
problem go? Will it give you like a starting point, or will it just?
It's gonna, well, hard. I mean, it depends. Is the question to make this final product, or is it to with like 5 steps, or is it
Jesus.
tell me what this and this are? Like, there's no way to know. It's kind of like, imagine like you have a puzzle that's partially put together. You have to figure out what other pieces you need to make it complete, right? And those pieces might be complex, where like 3 big pieces make one, or is it just a single piece? Just depends.
Wait, are we gonna need to know MO theory?
MO?
Is that part of?
It can be. Wade did it in the very beginning in Unit 1, but
Oh,
it
okay.
barely touched upon it. I don't
Yeah,
think you're going to see it too
Because
much.
I remember,
Bonding, anti-bonding.
yeah, at the end of Gen Chem 3, we kind of went over that. I didn't get it.
It's possible. It's
We
possible.
had that in Gem Chem too, I think.
Yeah, you guys probably had it where you had to show like the
We had to do
weird,
it for exam
like, almost
two.
like a weird like
had to do it for
signal
exam
ring
two.
almost.
Failed.
I got 68.
Wait, what?
I got 68. I still got A in class though.
Okay.
Yeah.
I would say the MO theory is
I came
probably
back
not your
on the
major
final.
idea though.
Came back with the final. Knocked that shit out of the park.
Alright. Okay, so
No, on the
what
final.
about this guy now?
The second exam. The exam replacement policy. Thank God.
Reactions with Grignards
That would've been cool.
and cyclic esters. So it's an ester, which means you can do it twice, right? But it's cyclic.
Cyclic.
Okay, so a cyclic ester,
Gen Eds were more work.
There always are.
okay, is going to have the excess,
Took us to stupid Gen Ed in like India.
right? Excess R, MGR, VR, whatever that is,
Never have taken that course.
H3O
I thought
plus.
it would be easy because I'm Indian. I know that shit.
Okay, here's the difference.
Never.
You used an ester last time, and how many different alcohols did we create? Two. So if it's a cyclic structure, can it break apart into 2 separate alcohols? No, 2 separate
No.
actual structures. No, it's cyclic, right? Which means it's going to be one big structure with 2 OHs. This is making a diol. It's a diol. Okay, so let's take a mech. Okay, so watch the thing I'm doing here. Cyclohexane normally, I'm just putting an O here and the carbonyl here. You see how that's a cyclic ester. The
Yes.
ester's embedded within the cycle. Okay? Alright, first step, you're going to do some kind of nucleophilic attack. So I'm just going to choose CH3 to make it simple for us. Okay? So first step, MGBR. CH3 comes in, it's going to go where?
CH3 will go to the ester.
The carbonyl, right?
Yeah.
So carbonyl, pop, right? Breaks open, boom. Okay, so then O minus, right? Then now you have this CH3 on there too. Okay with that? And you still have your oxygen kind of sitting there.
This dial I did.
Okay, so this is the same first step you saw before, nucleophilic attack of the carbonyl. What was the next step we would normally see with esters next?
The first step you'd see with what?
So what was the second step we would see now with esters after they've
Probably
gone
the
through this addition?
pronation of it.
No, that's the very end.
Wait, what?
Oh,
What makes
double
that?
bond?
So what happened last time was this. You have this.
Wait, what makes that an ester? The O in the
Yeah, oh, right there.
in the ring?
Mm-hmm. Just cyclic ester. So what will happen last time is this formed after you added another whatever group. This is what happened because you made a double bond, right? Draw, right? So you see how that lone pair of electrons made the carbonyl, and then that was a good leaving group. What's going to happen then here?
After that?
It's a good leaving group, so I can
Oh,
literally
so leave
break
the
all of the
OR.
ring.
Oh my god.
The ring opens up. The ring opened up. and then that means then the carbonyl, right, will form. So let me go back to the
Wait,
mech
what
here.
does this have to do with what's on the bottom?
What do you mean? Oh no,
The
he's just
leaving
showing
group.
the leaving group.
I'm showing
of
how
OR.
before this how esters work with non-cyclic.
Oh.
So what would happen here cyclic? Okay, so what happened officially in this is the lone pair of electrons came down, right? Right, okay, and then you had to have some kind of a leaving group occur, right? So then this guy leaves. So then that means you have this. Sometimes you have to make it a little bit bigger to really hope we get it. So carbonyl there, right? This is the new methyl. Right, that's the new methyl I just had on there, because that's him. Because this bond broke, right? That bond broke. Okay, so that means it's here. And that new bond, yeah, that new bond becomes that lone pair on that oxygen now. So you have that guy.
Okay.
Okay. So what with esters, we also saw that you can do not only one Grignard, but you can do two Grignards, right? So your second Grignard, right, would be CH3MgR, no GPR. Okay, so it's going to attack the carbonyl as well.
Huh? No, I was looking one.
What?
Someone's moving on their chair. So it's on.
Okay, there, got that structure.
How did the ring close back?
Oops, sorry. That's my normal go-to.
Surrounds.
That's my normal.
Like,
There, and then I added another CH3. There it is, okay? So at this point, can I force the carbonyl to form and then have another leaving group?
Wait,
Can
those-
you?
So
Are those
can-
methyls
can-
or S?
These are methyls. Those are methyls.
Oh.
So can I move this lone pair of electrons down here and then have something else leave?
No.
No. So that means the Grignard I've already done my two, I'm done. Ketones and aldehydes could only do one because there was no other leaving group. So now at this point, we're going to protonate it. Do you guys need to show the mech on that part? You're okay.
I think we're good.
Okay.
So both protonated.
Mm-hmm.
Protonation. Just two H's going to them.
So then you get one and you get one.
We're gonna make everything complicated.
There's your dipole, two OHs.
Wait, what's the definition of an ester again? If the O is between the carbon.
So this is a carbonyl, right?
Yeah.
That's a ketone if both are carbon groups, right? That's ketone. That's ester.
So this is a ketone ester.
So this is an ester that broke apart and formed a ketone.
Oh, but isn't there already a ketone?
Yeah.
That's an ester right here. That's
Ester.
How,
That's ester.
I thought it's a.
And
No,
then
one
it
has
happens,
the
it
O
forms,
attached to it.
so it forms here. That's the ketone forms.
Oh, okay, okay.
And we learned earlier that ketones will undergo it and make a secondary alcohol, right? Okay, but it can go through tertiary to make an ester. But you get two of them out of the deal with this case. Because the cyclic ring stays a ring, right? The other OH just wasn't like thrown off into space, it's still attached to the big structure.
But it just breaks.
So it's still there.
So leaving group. So whenever you have a leaving group,
An extra carbonyl,
whenever you have a leaving group in a ring, it just breaks the ring.
as long as the carbonyl is free forming first, then it has nowhere to go but out.
Yeah.
In this case, it was to break. Okay, thoughts, concerns, how we doing? Okay? All right. Okay, epoxides, which we know can form first if you wanted to from phenoxyacetic acids, right? MCPDA, things like that. Okay, so in this case, the epoxide will react with the Grignard and also an equivalent of H3O+. So same idea. It's going to make a primary alcohol. mechanism for that. Okay. And now before we saw carbonyls were available for attack. That was pretty easy to see. There's no carbonyl here, right? So we can't really easily see which attack is going to occur. It doesn't matter in this case. Okay? So I'm stating this very loud and clear. In this case, it doesn't matter which carbon it would go after,
What do you mean?
because this would be an SN2 attack.
Is this?
Oh.
Is it just not
Because if it
symmetrical?
was, so this thing, if it had a bunch of methyls on it or whatever, it's not gonna go there,
Oh.
right? It's an SN2 attack. So if it had a lot of methyls involved or whatever, it's not gonna go there. Okay? So in general with this one, SN2 attack, R prime, you can choose whichever one, I'll just choose that one. Okay, when that happens, it can't hold on to an H and R in that bond too, so it's gonna
Break it.
break, just like we saw with the Vesta, right? So if that's the case, then we have R added. He's added to this one. Right? Yeah. There's one. Okay, R added to one.
So it just breaks
Two.
that bridge between the O and the.
Mm-hmm. Yep, because this is the carbon added on. We'll call it one. We'll call it two. Right? 1, 2. So that R group got added to position number 1, 2. That means the OH has to be up there then, after you protonated, of course.
Oh, okay.
And then the H3O comes in.
And that protonates the O.
Mm-hmm. Pop. Pop. Okay. So these groupings here, right? Whatever's here is whatever is here. So if you make it big and bulky, this won't go. Right, remember, it's got to have SN2 attack. It's got to be fairly small. Now, so if it's a simple epoxide like this one, doesn't matter, they're next to each other, who cares? But if you have an epoxide with something on it, then we have to worry about it.
Wait, what? Is there a little dash next to that carbon on the right? With-
No. Okay. I just didn't show it there.
Wait,
And I'll put a 1 and a 2 here just so it's clear which carbon those are.
Oh, okay.
Okay, and this is carbon 1 and carbon 2, just so it's clear, you know, which ones on the epoxide it belongs to.
So it just breaks the like ring structure.
It breaks it up,
But
just
it
like,
makes the
just like
same
cyclic.
structure regardless.
Just like cyclic did, right? It's just a different version of it,
I
not
see.
using carbonyl instead. Because remember, epoxides opened up for diols, right? Remember that?
Yeah.
So same idea. Or halohydrogens or anything like that at all. So just be aware of the SN2 limitations when you're considering which one of those carbons to attack.
What do you mean?
So if you had an epoxide that was present that formed that had 2 methyl groups on it here. If you have an SN2 reaction, that means you want to have least stereokinates, right? So if you have methyl here and methyl here, which carbon are you going to go after?
Oh. How can you tell?
This is big and bulky, right? I mean, I see kind of R
It
group
doesn't
going-
matter. You just go after that
I'm
one.
going after somebody. I mean, if I go here, I'm dealing with this coordinary area here. Like, why am I going to go there? That's too hard for me to
why
get
would
in
you
there.
go there?
So it's going to choose to go to the least stereokinase area. That's what that means. Have you seen a lot of epoxides with stuff on them? No, we haven't. Does it mean it's possible? Absolutely. Okay, how are we doing there?
Does an epoxide even want to exist?
This is good.
Epoxides can't exist like with stuff on them, like substituents. They
Oh,
can't.
the orange one?
Yeah, blood orange.
Okay. All right, here.
Better not lie to me.
Okay.
Oh, my fault. This is the best one.
Written products with
Is it
multiple carbonyl bonds.
What?
Okay, ready? it's great and all if you only have one carbonyl, you know which one it's going after. What if there's multiple in there? That's the question. Okay, so 1. The most reactive to least reactive. Okay, most reactive with things like
Grapes.
waters or alcohols.
No, I'm touching mine.
We'll see.
So water, alcohol's gonna be really reactive with the carbonyl. Okay. Aldehydes, they're pretty reactive. We've seen that before. Ketones,
You have a computer.
I don't feel like flipping it.
esters,
My phone's dead.
in order. So if you had a structure that had an aldehyde and a ketone in it, it would prefer to go after the aldehyde over the ketone if it could.
That's H2O or
Or
alcohol.
Yep.
Who is it?
Okay. So if we had this reaction happen, and I had only one equivalent, meaning non-excess of that phenyl in your reagent.
Wait, what does it say? H2O.
Yeah, H2O or alcohol.
Oh. So bad at reading.
Wait, so you're saying if it's already alcohol?
So it's, no, I'm saying that here, yeah, sorry, alcohol's done, yeah. So if it's an aldehyde, it's really reactive and whatnot too.
Wait, can you explain like what?
So water or alcohol are gonna go after carbonyl bonds really well because they're small, right? It's an SN2 reaction,
Well, what does it say above the reagent?
one equivalent,
Okay.
so non-excess. We saw earlier that excess would go after everything, right? Esters included. I'm saying if only one equivalent went in here, what's gonna
Oh,
happen?
it's gonna go after the alcohol.
It's gonna go after which one? You have an ester and you have a ketone. Which is it gonna go after?
The
Ketone. Ketone.
It's going to go after the ketone because it's more reactive compared to the ester. So that means the ester remains intact.
Ester.
Right, which is this thing turns into an alcohol then, which we know that this becomes an OH. That methyl stays there. Then we're going to add on this thing, which is the phenyl. If you did the same exact reaction, let's do it this way. Do the same exact reaction, but now hit it with excess. Means no one's safe. That means even the ester gets knocked. Okay? If the ester gets knocked, this is tricky.
So would there be 3?
So the first step would be you gotta remove this RO group, because that's gonna be an amine group later, right? So you know that CH3OH has to be one product later down the line. And we also learned that esters, because getting 2 equivalents, is gonna have 2 phenols on it as well. So that would mean, right, that this OH, that stays the same, that becomes OH, right? And that stays the same. This was the first phenyl. We could go on it because that was going after the aldehyde, right? But then the ester got attacked too, and it gets hit twice. It gets hit by the phenyl not just once, but twice. So you have a phenyl here. Yeah. So a phenyl here, and another phenyl here.
It's gone.
Pushed it back up.
Okay.
Wait, why is there only one OH on
Just
the left side?
On here. Because remember the ester can only make a tertiary alcohol.
How about the other O? Like,
Yeah.
how are there 2 phenols?
It's called dark.
Because remember you had 2 equivalents. The first one would get added.
I think
So,
the demo
you had this.
children.
This guy goes bye-bye, right? So then this was added on first.
Exploration.
That's a ketone, right?
Yeah, it's like you're a
Ketone now
thief,
means
and then you
this is gonna attack again,
attach
Oh.
it.
right? So that's two of them.
Yeah, wait, why are we missing an OH on the bottom left? Where'd that go?
Not here?
It looked interesting.
No, where the bottom left phenol ring is. That replaced the H3CO.
So,
No, because that's gone, it's not
Sal would
there.
put anything.
Oh, okay.
He just
So
Yeah.
that's the
needs
first part,
somebody
that's like
to
the
put
first leaving group thing, right?
So the whole entire group leaves. Okay.
That's where you get two separate alcohols usually.
Mm-hmm. Oh, that is all.
Okay. All right. Now I'm gonna give you just one last piece of advice here. Okay. On here.
so wait, how come there's two of the little like rings on the?
Because you had to have two equivalents added when we did the Grignard for esters.
Oh.
That's like a telltale sign you have a Grignard reagent with an ester reaction. Okay, so if your given product is tertiary alcohol, your clue is going to be that all substituents are different. And that means that the reactant must have been, or reagent, should have been a ketone. If it's a tertiary alcohol though, and it was two or more, substituents are the same. Now you had to have two for the ester, right? So this is an ester. Two additions. It's a secondary alcohol. There is no clue. There's nothing that can tell you like, oh, that's gonna be it for sure, because only aldehydes can do it. It's a primary alcohol, and the product has
Would not be.
two additional carbons. Okay, so I've added two more C's to it. That's gonna be the epoxide. It's a primary alcohol. And the product is only added one thing. Then that must be formaldehyde. Formaldehyde only has one carbon. So it's kind of a little bit of a synopsis of Grignards. It's only Grignard though, okay? Grignard cheat sheet.
Wait, how are the first two different?
So the ketone will go ahead and react. So you have R prime, right? Like that. You're adding a Grignard to it, which is R double prime. Boom. So you're gonna get R, OH, R double prime, R prime. So there's your tertiary that all are different. Now, it doesn't mean they can't be the same. Be aware, that doesn't mean that. It is possible.
But what if the very product has one addition?
Additional carbon.
One additional carbon, then that would be the epoxide. Or so two is going to be epoxide, second one's the formaldehyde. Okay. We were close. We were getting there. We got about halfway through. All right. Well, there's another like big component of it later, which is sodium borohydride and lithium aluminum hydride, which is pretty big later. Okay, question. Okay. I pulled questions before, but the problem is some of them relate with everybody here. Okay.
It's over, Prayon.
It's finally over. Okay, so we can have to do naming, we know that for sure. 10 dash, okay. So 10. Oh, I'm not gonna do that.
This is by far the best one.
Chapter 10 dash 30. B, C, D are fine.
The fuck is
A,
ashwagandha?
B, C, D.
Ashwagandha.
Yeah.
Oh, it just makes your like you emotionally numb. I took some in December. It kind of fucked me up for a few days. So I stopped taking it. Like you just don't have emotion.
Zombie.
Yeah, yeah. Just, like you
31
become like
E.
focused, but it like upset my stomach too. So I just didn't like it. It felt weird.
Oh, that ashwagandha stuff, but it's
I
called.
did wait. So it just changes your emotions.
Yeah, like you
It
just
numbs them.
yeah, like you just don't like feel. Much.
So wait, then why is it let's say happy?
Well,
It does.
you don't-
It
you don't
minimizes
get
your depressive thoughts.
sad.
Put that way.
Like-
it
like
it
you
minimizes
just-
depressive thoughts.
Like you just don't care about anything.
Well, you're not lackadaisical about it necessarily, but you
Well-
are just a little bit like you're just. It's not going to bother you as much as
Yeah.
it could.
Is there an organic formula for this?
Well, I'm sure there's like multiple that are in there.
So if I bomb a test, I could just take.
You'll feel
shots
better
of
about
this.
it later, right?
Like it's not that. It kicks in after a few days. You like really feel. You have to like take. It was like a
Well,
supplement.
what if I just took this?
So just take it a few days before you take the test.
Is there
so
another one?
once you bomb, you'll be ready.
Sure. No, it helped me like lock and helped me like work a lot, but I just didn't like.
So it's like Adderall.
I don't know. I've never taken Adderall.
Well, nor have I, but
Oh,
that's what
no.
it sounds like.
Well, I'll
No,
have to
it's-
take it. to know what
it's
it
It
not.
feels.
just helps you focus.
It wouldn't be similar to Adderall. It'd be similar to antidepressants.
Mm-hmm.
That's stupid.
Yeah, it was a weird.
What put happy?
Bro, why would they put? Why would they lace
So
this
wait,
with
why'd
Adderall?
you take it?
I just want to try it. Like me and a few of my friends tried it. We went to Fresh Time and they had like a bottle of like
So your
ashwagandha.
friends
pills.
try it. It's okay. You to try. Okay.
Yeah,
Yeah, I
well, it's
take
ashwagandha. It's not
cocaine.
drugs. Like, it's not cocaine or some shit. But,
You jump off a cliff?
oh my God.
Yay.
I can't believe you jump off a cliff, man.
4.
Luckily, you took ashwagandha. Got that good. God.
36. Can we do 36 yet? Okay. Now I can work some of these.
Bro, it's like
Some of
basketball
these can be done.
yesterday. I'm gold.
Anything green you can
Actually-
actually now. 36.
Well, I was playing it, but
Okay.
Where are you playing?
at home.
C.
Oh, that's at you.
Yeah, with
Nice.
broken home. Actually, it's impossible not to score.
F.
What do you mean?
Hit the backboard once.
You banked it in.
H.
You can bank anything in. The ribs like this.
Why is it pop not be done?
Oh, it's like.
J cannot be done. K no.
Always goaded.
L no. N. I think it's the weird old stuff. Let me do that. So that's 36. 36. 39.